Hello everyone, I'm Dimarme Alonos and I'm here to talk about the classifications of matter. Our first objective is to distinguish the differences of the properties of elements and compounds. Second, differentiate homogeneous and heterogeneous mixtures. Third, perform different types of separation techniques for mixtures. Before we're going to classify them, let us know first what is element and compound. Element is a pure substances which cannot be broken down by chemical means, while the compound is a chemical substances formed by chemical bonding two or more chemical means. So these are the 5 things and we're going to classify them either a compound or a element. First, this perfume is a compound because it contains more than one element. Second, this pencil is element because the great tip of the pencil is composed of graphite, which is the stainless form of the element carbon. Third, this salt is a compound because of its stable structure formed of 2 chemical elements. Without chemical action, the salt will remain as it is without breaking down or attaching other atoms or molecules to itself. Next, this gold necklace is a pure element because of the gold is found in the periodic table. And lastly, the sugar or sucrose is a compound because it is composed of carbon, hydrogen, and oxygen elements, and it has the formula of C12H22NO11. So in the next procedure is we're going to differentiate the homogeneous and the heterogeneous mixture. Before we're going to differentiate them, let us know first what is homogeneous and heterogeneous mixture. Homogeneous mixture is a solid, liquid, or gaseous mixture that has the same proportions of its components throughout any given sample. While the heterogeneous mixture is a mixture which the composition is not uniform throughout the mixture. So we have 4 samples here and we're going to know whether it's heterogeneous or homogeneous mixture. So in our first experiment, a pinch of salt and 3 tablespoons of water. Salt water is a homogeneous mixture because the dissolved salt is evenly distributed throughout the entire salt sample. So in our next sample, a pinch of chalk and 3 tablespoons of water. A true solution has solute completely dissolved in solvent. In case of chalk powder, it does not completely dissolve in water. Hence, chalk powder in water is heterogeneous mixture and is not a true solution. So the next experiment is the sand combined with the body powder. Sand and body powder is the heterogeneous mixture because sand and stone form a mixture. Since the particles are not uniformly distributed, we can still see the individual pieces. So last in the experiment is the oil and water. Oil and water is a heterogeneous mixture because oil and water do not mix, instead forming 2 distinct layer phases. Therefore, oil phase is less dense than the water phase, so the oil floats on top of the water. So last in our procedure is to perform different types of separation techniques for mixtures. There are 3 ways to perform separation techniques. First is the evaporation, second is the filtration, third is the sieving or sifting. So first to perform is the evaporation. Evaporation is the process by which liquid changes into vapor to gas. So my example in the evaporation is the hot water and the salt. When we use heat, the solid, which is the salt, will be soluble to its solvent, which is the water. Second is the filtration. Filtration is the process of separating solid and liquid substances by using a porous filter, such as cloth or strainer that allows liquid to pass through. So for my example is the separation of oil from water. To separate oil from it, I use a funnel to transfer the liquid to the other bottle and the oil will stay at the funnel. So lastly, the sifting. Sifting or sieving is the process of using a sieve to separate solids from a different particle size. For my example is the sand. I used a kitchen strainer to separate large sizes of the rock from the small sizes of the rock. So that's all for today and thank you for watching!